19, 23, 25. Any other questions?
No.
What one? 15. Anything else, you guys?
Yeah, I think it's you. I think it's this. Yeah. I was sitting in it, it's really funny.
So I forgot to show them a sample of one of those, so.
Okay, no, that's fine. Okay, so let's go through these questions. Just a quick reminder, if I need to see you tomorrow, you got a Google Meet for me. If you did not get a Google Meet, maybe Ms. Miller needs to see you, but I think she'll be sending you one soon. But if you want to see one of us, let us know. We can schedule something. I do have a few open slots. But if you get called to come in virtually, you should be doing that, please, so that you can do the makeup work or corrections or whatever it happens to be that we want to see you for.
And just so you guys are aware that if you don't show up for that, then they will require you next Friday to come in person. If you don't show up for your meets, if you get one.
Yeah.
Okay, Brody.
All right. So in number 15, I have to find all the missing sides and angles. So when it says solve, we want to find all the missing sides and angles in the drawing. So the first thing I'm going to do is I'm going to find the missing side here. So I'm going to call this like little a. And I can do Pythagorean theorem to find that. So a squared plus 14 squared will give me 16 squared, because this is my c value. So I'm going to find little a because that seems like the easiest one to find right now just because of Pythagorean theorem. So move this over. So if I know a squared is 60, so then a is the square root of 60. Which you could write as a simplified radical, 2 squared is 15, or you can write as a decimal as 7.7. So that's a little a. Now we want to find the angles. And so to find the angles, I'm going to start by looking for angle G. I'm going to label everything based off of angle G. So I have my opposite side over here, my hypotenuse, and then my adjacent. Now, I'm not going to use the opposite side. The reason for that is because opposite is a decimal, and I prefer to use whole numbers if I could. So I'm going to use the adjacent and hypotenuse to find this. So adjacent and hypotenuse for SOHCAHTOA. So I'm going to use cosine because of the fact that I like to avoid that opposite side just because it's a decimal. It's just a little more exact. Just working with whole numbers is easier than decimals. So cosine of G equals adjacent over hypotenuse, so 14 over 16. And then when I'm trying to find angle G, I have to do the inverse cosine of that 14 over 16. And that'll give me my angle G, which again, you need your calculator for. You won't be able to do this in your head. Make sure you're using the right trig function. And so I got like 29 or 28.955. So basically it's 29 when you round for my angle, or 29.96 or something like that. So that's my angle G. And once I know angle G, then I can find angle J, because this is 90 degrees, and we know they add up to 180. So my leftover is 61 for J. So that's our other angle. Now in 19, they make a mistake when they set this up. So you're trying to find their mistake. I don't even know if they ask you to solve it, so they just say find a mistake. So in this triangle here, they have WY, and they have that being 7, 36 degrees. And then they say sine, inverse sine, so sine -1, 7 over WY equals 36. So kind of a weird problem. So what they're trying to get you to see is if you were trying to solve this, hopefully you guys just realize that sine is so. So if I'm talking about 36 degrees, which is what they mentioned here, the so is opposite over hypotenuse. So here's my opposite. When my hypotenuse is here, so I wanted to set up this ratio this way, it'd be 7 over, not WY, which is this, that'd be 7 over 7, it'd be 7 over WX. That's all they're asking you to do, is kind of see what they have set up wrong there. And then 23 and 25, as you guys were kind of finishing up yesterday, I talked about 21. 23 and 25 are supposed to be really, really similar, and they weren't meant to be difficult. Like they're so straightforward that you probably think you're doing something wrong. Basically, it's just punching things into your calculator. So cosine of A equals 0.33, and tangent of A equals 1.0. So just like yesterday, if I was showing you guys a fraction, and I said like sine of A, or let's do sine of B, equals 3/5. If I want to solve for B, I take the inverse sine of 3/5. You guys recall? Now, rather than saying it equals a fraction, they're just saying it equals like a decimal. So if I'm trying to find the value of A, I'm just going to do the inverse cosine of this decimal in my calculator. That's all it's asking you to do. Just kind of rearrange that and solve it for A. So the inverse cosine of 0.3 repeating, or 0.3 I guess, it doesn't say repeating, it's like 70.7. The inverse tangent of 1, and this one's going to be 45. I just know that one because it's an easy one to know. So A is 45. Okay? That's all they're asking you to do. And just understanding that you can solve that. So we're going to get going in notes here. I'll get you guys, we're actually doing this chart today. So we are actually testing on Tuesday. We're going to review for the next couple of days. We're going to review today, and then we're also going to review on Monday, and then test on Tuesday. Like throughout the whole day Saturday, they're saying, right? Like,
Well, I'm like,
are they even here?
yeah, I know, I'm always saying, I'm so,
Yeah.
I'm not, like, no one there's risking.
guys, listen up, please. So, we're going to kind of go through all the different topics we talked about in this chapter. I'm going to tell you guys right now, this sheet doesn't go in particular order. It kind of does, but then I realized I missed a section. So if you look at the back, the last two are actually from like section 2. So it's a little bit out of order. So if you're trying to follow along with your notes, it's not going to match up exactly. So, like what we're going to be doing here is, again, writing our formula, writing maybe a picture, and then a quick example that goes with this. So, I thought we could do an example that's like a little tougher Pythagorean theorem example. So, and if you run out of space, you can always use your margin. Otherwise, the backside has a few open blocks as well. So let's do. So let's find the value of x here. Now I wanted to include something that has a more complicated side length rather than just being like a whole number. So just reminding you guys how to simplify or how to square something like 8 square roots of 5. So 8 square roots of 5 has to be my c. And I'm going to do a squared plus b squared equals c squared. Now, I'd be careful to put that 8 square roots of 5 in your calculator and make sure you put parentheses around it. Otherwise, it's going to try to like simplify it in the way it shouldn't. So this is 100. But then 8 square roots of 5 should be, it's a pretty big number when you, I believe it's 320. Do you guys get that when you squared that? So if you didn't, you have to put parentheses around the whole thing and then square it or multiply it by itself. So just a reminder, 8 square roots of 5 times 8 square roots of 5 is really going to be 64 square roots of 25, which is 64 times 5. So a pretty big number there. So I'm going to move this 100 over. So to solve that, take the square root of 220. Which then as a decimal is like 14.8. Or a simplified radical like 2 square roots of 55 or something crazy like that. What's that? It's crystal light. So like this quick looks like a little. It makes me drink more water when I put some sugar. Yeah, well, crystal light's not sugar, it's a fake sugar. But yes, so yeah, basically it's probably worse, like Mr. Johnny who doesn't like crystal light, because it's not really that good for you. Whatever. So on a problem like this, one of the main things, guys, is when I keep like kind of saying, make sure you grab your calculator, make sure you put this in your calculator. If you guys get to the test and can't figure out how to put something like that in your calculator, how to go from this to the answer, I can't really help you when you're on the test. That's not a fair time to say, can you show me how to enter this into my calculator? So making sure you guys know how to use the calculator you're using. All right, so then we got into our 45, 45, 90, and 30, 60, 90 triangles. These are the ones where you really probably want to have one of the calculators that simplifies the radicals for you, because of the fact that there's a lot of work with radicals on these. We have leg square roots of 2 for our 45, 45, 90 triangle. So in this case, I tell you these are both x, and then I tell you this side is 24, and I want to find the value of x. Now, to be honest, you could actually be a little bit savvy and use trigonometry to do this. However, I think technically a 45, 45, 90 should be easier to do than using trig, but it's kind of up to you. This one I'm going to want my answer in a radical form, or a simplified radical. So So if I know the hypotenuse, how do I go backwards? Yeah, we're going to divide by the square root of 2. So I have to do 24 divided by the square root of 2. Now again, if you have the calculator, it simplifies really nicely. This will be great. If you don't, then you'll probably be annoyed here for a second. So you have to multiply by the square root of 2. And so it's going to end up being 12 square roots of 2. So if you know that you don't have one of these calculators that simplifies radicals, I would suggest trying to talk to someone else that maybe has one. I have some in here, but I can't guarantee everyone would have one. So if it means you guys talk to someone in my first hour of geometry, there's a lot of them in there, and maybe you can just use it for that class. I just can't have you passing back and forth. Like if I did the question and then just handed the thing to Bella during the test, then really she could just read what I'm doing. So I don't want that to happen, so I ask that you guys have your own calculator for the test. Or one of mine, but there's only so many of those. So that's 45, 45, 90. Then we have 30, 60, 90. That's the other of our two rules here. So this one we have the short side. We have the hypotenuse is 2 times the short side. And then we have the short side times the square root of 3. So again, I'll show you guys an example of that. We'll call this X and this Y. So in this case, they're giving us the hypotenuse is 10 square roots of 3. We want to go backwards. So we want to figure out X and then we want to figure out Y, because again, we always want to base everything on the short side. So you want to go to the short side first. So what do I have to do to go from the hypotenuse back to the short side? Divide by 2. So if I divide 10 square roots of 3 by 2, I get 5 square roots of 3. Okay? So that's our short side. Then to go to the Y, from the short side, I have to multiply by the square root of 3. So to get Y, I'm going to take 5 square roots of 3 and multiply by the square root of 3. So what's that going to end up being? 15. Square root of 3, square root of 3 is going to be 3. So 5 times 3 is going to be 15. So there's our two answers. Okay. So the next one is the geometric mean. And this is probably, I think, one of the tougher sections in this chapter. The geometric mean involved proportions again. So it kind of was like something that we probably didn't love. Proportions wasn't, I think, everybody's favorite chapter. That was last chapter. Is the fact that geometric mean means that X shows up, it's that common value that shows up twice. So we put it across from itself on the proportion. And what this looks like is typically, it's a right triangle with two sets of smaller right triangles inside, where that X is that shared side, and then we have A and B. That's kind of our most basic, straightforward example, if that works that well. So one of my tips for this is if you're stuck, try drawing separate triangles. And I'll show you guys what I mean. Let me find one that's like that. across is x. This little leg here is 7, and then this one's 9. And so the drawing's kind of flipped around. So this is not as simple of an example as this one. So I didn't want to grab one that I consider like a simple example. I thought I'd grab a tougher one. So this is one where I'm going to suggest you draw separate triangles. So if you're looking at this triangle, I know 2 out of the 3 sides. I know 7 and 9. So I'm going to draw that somewhere here. I don't have a ton of room. So I have 7 and then I have 9. But then on the big triangle, I know one of the sides and I'm looking for the other side. So I'm going to maybe just draw it down here and I can always move it. So the big triangle, on the bottom I know it's 9, across this way is x. So I can solve this using proportions. I know the hypotenuse here is 9. What's the hypotenuse down here? X. So I'm going to do 9 with x. I know the middle side is 7 here. What's the middle side on this one? 9. It would go with 9. So in this case, the proportion's a little bit different. I now have the 9s opposite each other because the 9 is like the shared side. So I would cross multiply and set equal, so 7x times 81, and then I would solve that. 7x equals 81, divide by 7, and so I'm going to find out x is like 11 point something. So sorry, I kind of ran out of space there. All right, so the next 3 are sine, cosine, and tangent. We'll do 1 or 2 of them and then we'll take a little break. So we're SOHCAHTOA. Would highly suggest the minute you get your test on Tuesday that you would write this down on top of your test along with any other formulas like a squared plus b squared equals c squared, the geometric mean. There's kind of all these smaller things to remember for this test, but it's kind of a lot, so that's why we're making a chart. So the sine of A, or sine of whatever angle we're looking for, so this is an angle, equals the opposite over the hypotenuse. And remember, those are sides, and they come from the fact that O over the H is kind of a giveaway for us because of the fact that the name is SO. It's just a shortcut. So we'll do a little example here. If this is 32 degrees, here's my x, and then I'll call this 12 up here. So this would be an example of what I would use sine for, because it's the oh no, sorry, that'd be tangent. Never mind, let me fix that. Go back, don't put that as 12. So 32, sorry, x, and 12 there. I don't want you to have to move it. But the 12 is the hypotenuse, sorry. So we have sine of 32. The sine of the angle equals the x over 12 because, again, we're solving for that opposite side. And so x is being divided by 12, so instead we'll multiply by 12. And I got like 6.4 for my x. guys want a little break? Yeah. Alrighty. All right. My other class, they did Pictionary.